Hello all, let us continue our discussion on EFM32GG microcontroller. So, in microcontrollers, uh, we have various types of interfaces, right? Whether it be serial or parallel. So, among the serial interfaces, UART is very common, correct? UART stands for Universal Asynchronous Receiver Transmitter. Now, apart from UART, EFM32GG12 has something called LEUART, which is called low energy UART. This is one of the interface which is present only in this microcontroller, and LE, as we said, stands for low energy UART. So low energy universal asynchronous receiver transmitter. So what does it mean? So if we see here, we have a UART, which is basically a full duplex kind of communication and an asynchronous interface, right? So what happens? You have data that is being received, and then CPU processes the data based on the data received in the registers, and then if required, it communicates back or whatever the entire processing happens inside the chip. Now, LEUART, how it is being achieved is this is done with minimal CPU intervention. So, how does that happen? It happens by having a DMA controller, which basically helps us receive the data and push it to RAM, and then the CPU is waken up, and CPU acts on the data. That means during the entire process of data received, the CPU can be in sleep, which meant LEUART can be used in sleep states as well. So LEUART, as we mentioned, can work in sleep state as well. And this works basically on 32.768 kHz. Right? In sleep state, you generally have the RTC clock up and running, and because of this particular 32.768 clock, the maximum baud rate that can be achieved with LUART is 9600 bps. And as there is a minimal CPU intervention, the power consumption is less. That is why we call it the low energy watt, and which is one of the very important feature of EFM32 GG12 microcontroller. So you can check out the datasheet to see what are the pins that are supported, and if you want to use your UART in low power states, you can use LEUART.